Hey, welcome to The Explainer. Today, we're diving into something that sounds like it's straight out of a sci-fi movie, but with one major difference: it is very, very real. It's called the Kessler Syndrome, and it's this chilling idea that we could get trapped on Earth by a cage of our own trash. So, let's get into it.
Just think about your day for a second. Did you use a map on your phone? Check the weather? Maybe buy something online? Every single one of those things depends on this invisible web of satellites orbiting right above our heads. Our entire modern world runs on this infrastructure. So what happens if that gets threatened?
Take a look at this number, $1.4 trillion. That's the estimated economic value from just one system, the U.S. Global Positioning System, or GPS. We're talking about over $1 trillion in economic activity that is completely dependent on a bunch of satellites. It's a pretty stark reminder of just how much we've bet on having access to space.
All right, so let's dig a little deeper into just how much we rely on this lifeline in orbit, because it's about way more than just getting from point A to point B.
Seriously, from the giant container ships that bring us pretty much everything, to the high-tech farming that puts food on our tables, our whole world is basically being run from orbit. Financial markets, power grids, air travel, all of it needs that constant stream of data from space. This hidden network isn't just a nice-to-have, it's like the planet's central nervous system. And here's the kicker: it's incredibly vulnerable.
Now that we've kind of set the stakes, let's talk about the threat itself. It all started with this really chilling prediction from a NASA scientist named Donald Kessler, way back in 1978.
Kessler's idea was terrifying because it was so simple. He figured that if you get enough stuff in orbit, just one collision could create a cloud of shrapnel. Then each tiny piece of that shrapnel becomes its own projectile, its own little bullet ready to cause another collision, which of course creates even more shrapnel. It's like a domino effect in the sky, a chain reaction that could eventually wrap our whole planet in a deadly shell of junk.
And when I say bullets, that is not an exaggeration. Think about it like this. A rifle bullet is fast, right? About 1,800 miles an hour. Well, orbital debris is moving at nearly 10 times that speed, around 17,000 miles per hour. And because of basic physics, that insane speed gives it a devastating amount of energy.
This chart really puts the danger into perspective. Even a tiny fleck of paint, something smaller than a grain of salt, can hit like a sandblaster up there. A piece of junk the size of a marble can punch right through the wall of a spacecraft. And anything bigger than a softball, that's a catastrophic explosion, creating thousands of new bullets. The real nightmare, though, are the lethal non-trackables. Debris that's too small for us to even track, but still big enough to completely destroy a satellite in a blink.
For a long time, Kessler's prediction was just that, a theory. But over the last couple of decades, a few key events have shown us that this isn't some far-off what-if. It's a real and present danger.
Okay, so Kessler's original timeline might have been a little off, but his core idea has turned out to be tragically accurate. A series of really catastrophic events has shoved our orbital environment dangerously close to a tipping point.
So this number, 3,378, that's how many new pieces of trackable junk were created in a single moment back in 2007. China tested an anti-satellite weapon, and in an instant, it increased the amount of debris in low Earth orbit by almost 30%. And because it happens so high up, that debris is going to be haunting our skies for centuries.
Then, just 2 years later, something happened that people thought was basically impossible. An active American satellite smashed into a dead Russian satellite over Siberia. It was the first accidental crash of its kind, and it created these two huge clouds of debris that have since smeared out into a dangerous ring around the entire planet.
And that brings us to right now, where this problem is just accelerating. We're launching satellites faster than ever before, mostly to build these so-called mega-constellations for global internet. But as we race to connect everyone on Earth, we're creating a huge new problem up in space.
So what you're seeing here is this huge shift in what's actually up there. For decades, the biggest worry was junk from old explosions, but now, with all these mega-constellations going up, we're adding thousands of new active satellites. In the busiest orbital highways, there are now just as many active satellites as there are pieces of junk, which, you can imagine, dramatically increases the risk of a cosmic traffic jam.
Now, it's true these modern satellites are pretty smart. They're designed to use AI to automatically dodge any big pieces of debris we can track. But here's the thing, that smartness is super fragile. One solar flare, one little software bug, or just running out of fuel. And that high-tech satellite instantly turns into a dumb, uncontrollable 17,000-mile-per-hour cannonball.
And this right here is what makes these mega-constellations so risky. A single crash inside one of these packed networks can increase the collision risk for every other satellite in that network by a factor of 9. It's basically a recipe for a localized chain reaction that could just wipe out an entire constellation with terrifying speed.
Okay, so this all sounds pretty bad, right? But it's not all doom and gloom. The international community is finally starting to take this threat seriously, and there's a real race on to come up with solutions before it's too late.
A huge part of the solution is just having stricter rules for space traffic. For a long time, there was this 25-year rule. You had 25 years to get your satellite out of orbit after it died. Well, now that's seen as dangerously slow. The new gold standard, pushed by groups like the US FCC, is a much tougher 5-year rule. Basically, the message is becoming really clear. If you put it up there, it's on you to get it down. And you've got to do it fast.
But just stopping new junk from being created that's called mitigation is only half the battle. Our orbits are already clogged with the ghosts of the space age. That's where the second part comes in, called remediation. We actually have to go up there and actively clean up the most dangerous stuff that's already flying around.
And this isn't some sci-fi fantasy. Missions like the European Space Agency's Clear Space One are already being built. It's basically a garbage truck for space. The plan is to send up this chaser spacecraft, have it hunt down a big piece of junk, grab it with a giant robotic claw, and then fire its engines to dive into the atmosphere, taking the trash down with it in a fiery blaze.
So, at the end of the day, what this all comes down to is realizing that low Earth orbit isn't some endless frontier. It's a fragile ecosystem, just like our oceans or our atmosphere. The solutions are there, we can do this, but it's going to take a global effort. The choices we make right now, in the next few years, will decide whether space stays open for exploration or whether it becomes a ceiling that traps us on our own world.